At DSEI 2025, Roshel showcased its new multi-purpose armored vehicle, the Senator Mine-Protected Pickup. Designed for modern battlefield conditions, it combines protection, modularity, and mobility. Built on a Ford F-Series heavy-duty chassis, the platform can carry a wide range of specialized systems, from grenade launchers to advanced counter-drone equipment. A standout feature of the Senator is its Counter-UAS variant, aimed at addressing the growing threat of unmanned aerial systems. Building on the existing APC, MRAP, and EOD versions, this vehicle integrates detection, tracking, and neutralization systems for drones. It can counter reconnaissance UAVs, weaponized drones, and swarming attacks. The platform's open architecture allows rapid integration of new systems and ensures interoperability with NATO command and control frameworks. In operational terms, the Senator can function as a mobile counter-drone node, providing sensor fusion, electronic disruption, and kinetic response depending on mission needs. The vehicle meets NATO STANAG 4569 AEP 55 standards, with Level 2 ballistic and Level 3 blast protection. Certification confirms resistance to 7.62 by 39 mm armor-piercing rounds, mine blasts up to 6 kg under the wheels or center, 25 kg side blasts, and 155 mm artillery fragments at 80 meters. Rollover tests also validated its performance on steep slopes and challenging terrain. The Senator pickup comes in 4- and 5-seat versions with a payload capacity of up to 3.5 tons. It is powered by a 6.7L turbo diesel V8 engine delivering 330 horsepower and 750 Nm of torque, paired with a 10-speed automatic transmission and all-wheel drive. Its dimensions, 6 meters long, 2.4 meters wide, and 2.5 meters high, make it suitable for both urban and off-road operations. Roshel equips the platform with modern electronic systems, including smart access control, fleet management, and remote connectivity. Production capacity of up to 140 units per month, combined with global availability of Ford chassis parts, ensures scalability and maintainability. The Counter-UAS pickup is intended for frontline operations where drones are a constant threat. Potential applications include convoy escort, protection of critical infrastructure from aerial surveillance, and deployment in peacekeeping missions. The Senator fills a niche between heavy MRAPs and lighter tactical vehicles, providing forces with a mobile, NATO-compliant counter-drone capability in a protected pickup format. The introduction of the Senator Mine-Protected Pickup reflects a broader trend: mobile counter-drone systems are becoming essential on modern battlefields. Conflicts increasingly show that small UAVs pose a significant threat even to well-protected forces. Roshel offers a practical, adaptable solution, combining survivability with advanced electronic integration. NATO compatibility and modularity highlight the vehicle's relevance for contemporary military operations. Overall, the DSEI 2025 presentation demonstrates Roshel's ongoing expansion of the Senator family, offering a compact, protected, and technologically advanced vehicle capable of responding to both traditional and emerging threats. At DSEI 2025 in London, MBDA unveiled Stratus, the new name for the Future Cruise/Anti-Ship Weapon Program, marking a significant step in European missile development. The presentation took place on September 10 at the company's booth, attended by UK Minister of State for Defence Procurement and Industry Luc Pollard and French DGA Armament General Engineer Gaël Diaz de Tuesta, highlighting the transition of the program into its development phase and the collaborative work between partner nations. Stratus is introduced in 2 complementary configurations. Stratus LO, formerly TP-15, features a low observable design with advanced shaping and materials to reduce radar cross-section and enhance penetration in heavily defended airspace, making it ideal for deep strike missions requiring discretion and survivability. Stratus RS, formerly RJ-10, is optimized for rapid strike missions, relying on high speed and maneuverability to overwhelm defenses and engage mobile or time-sensitive targets. Both variants share a modular architecture compatible with air, sea, and land launch platforms. They integrate advanced guidance, navigation, and targeting systems capable of operating in GPS-denied or electronically contested environments. Their mission set ranges from long-range precision strikes and anti-ship warfare to suppression and destruction of enemy air defenses and neutralization of high-value targets. MBDA emphasizes that Stratus is designed to operate effectively in contested environments. By combining low observability, high speed, and maneuverability, the program provides flexibility in modern high-intensity conflicts. The dual design approach allows coverage of a broad spectrum of operational scenarios while maintaining technological commonality, streamlining production and deployment. The program reflects sustained multinational cooperation, particularly between France, the United Kingdom, and Italy, with over 750 engineers currently working on Stratus. The successful completion of the assessment phase has validated the technologies and enabled the program to progress toward development. MBDA presents Stratus as part of Europe's ongoing efforts to strengthen defense sovereignty and capability, pooling resources and expertise across nations to achieve strategic goals. As Stratus moves into the next phase, it reinforces MBDA's role as a key player in European missile development. The combination of low observable and rapid strike variants demonstrates the company's intent to address diverse operational challenges. With its broad mission capabilities and the backing of 3 major European armed forces, Stratus is expected to see widespread adoption, strengthening its integration within NATO-aligned defense structures in the coming years. At DSEI 2025, Iveco Defense Vehicles introduced the Viking, an uncrewed ground vehicle designed to redefine battlefield support and autonomous operations. Built as a versatile platform, Viking merges hybrid propulsion, modular payload capacity, and advanced autonomy to meet the increasing demands of modern military missions. The vehicle's hybrid drivetrain combines a diesel engine with a high-voltage electric motor and battery pack, offering a silent operational mode for up to 24 hours or 20 kilometers purely on electric power. When fully hybrid, its range stretches to 250 kilometers, allowing it to sustain extended missions without compromising mobility or stealth. This combination of endurance and adaptability positions Viking as a practical solution for logistics, surveillance, and direct support roles in complex terrains. Mobility is another defining feature. The 6-wheel drive system, with differential locks and independent suspension, allows Viking to tackle slopes of up to 60%. Its compact dimensions, with a 3-meter-long chassis and 1.8 meters in width, and a payload capacity of 750 kilograms, make it highly maneuverable in urban and rugged environments alike. The vehicle's design also includes configurable steering and a robust suspension system, ensuring obstacle negotiation and operational stability under challenging conditions. The Viking's payload bay is highly modular, capable of quickly integrating mission-specific systems ranging from surveillance and communications equipment to weapon stations. This flexibility enables the vehicle to support a wide range of tasks, including last-mile resupply, casualty evacuation, reconnaissance, and fire support, making it a true force multiplier for troops in the field. Autonomy is managed by IDV Robotics' MACE system, which supports teleoperation, remote control, and advanced autonomous behaviors such as route following, obstacle avoidance, and follow-me navigation. The AI-driven sensors enable Viking to operate with minimal human oversight, increasing efficiency in logistics and intelligence operations while reducing risk to personnel. Designed for durability as much as intelligence, Viking can reach speeds of up to 45 km per hour even while carrying maximum payload. Its hybrid capabilities allow quiet movement in sensitive operations, while its sturdy mechanical platform ensures survivability during long missions in challenging environments. With Viking, IDV demonstrates how uncrewed ground vehicles are becoming a central component of modern armed forces. The platform reflects a growing shift toward robotic support systems that enhance operational flexibility, reduce risk to soldiers, and streamline battlefield logistics. As militaries worldwide integrate autonomous solutions, Viking stands out as a versatile and future-ready option for the next generation of warfare. At DSEI 2025 in London, Spanish defense company ARQUIMEA introduced Grifo, a modular multi-launcher system designed to deploy loitering munitions from unmanned ground platforms. Mounted on the Duma Spectre 8x8 UGV during the demonstration, the system integrates 5 Q/40 loitering drones, combining mobility, autonomy, and precision firepower in a single package. This presentation underscores the growing role of unmanned systems and loitering munitions in reshaping modern land warfare. Grifo is engineered for versatility, capable of being mounted on different vehicle platforms to suit a variety of operational needs. Its configuration of 5 launch tubes allows simultaneous or sequential engagement of multiple targets, providing a higher volume of fire than traditional single-launch systems. The modular design ensures rapid reaction and tactical flexibility, enabling collaborative operations with counter-drone jammers and other electronic warfare assets. ARQUIMEA complements the system with its Skyblock man-portable anti-drone device, enhancing battlefield survivability by neutralizing hostile UAVs. At the heart of the system is the Q/40 loitering munition, a compact drone optimized for short to medium-range precision strikes. The drone combines surveillance and attack capabilities, allowing operators to detect, track, and engage targets with high accuracy. Its loitering feature extends mission duration, giving operators the ability to confirm targets before committing to a strike, reducing collateral damage while increasing operational efficiency. Equipped with a 40 mm class warhead, the Q/40 is effective against armored vehicles, fortified positions, and mobile threats, providing a cost-effective and resilient precision strike option even in electronically contested environments. The development of Grifo draws lessons from recent conflicts, including Ukraine, where drones and loitering munitions have significantly influenced combat operations. By offering a multi-launch capability, Grifo allows forces to maintain sustained fire on the battlefield without immediate resupply, increasing operational tempo and giving commanders greater flexibility in executing coordinated strikes. Strategically, Grifo represents a clear shift in European defense priorities toward unmanned and modular systems. Pairing an autonomous ground vehicle with intelligent loitering munitions aligns with NATO goals to improve precision, survivability, and adaptability in high-threat environments. The system reduces exposure of personnel to frontline risks while delivering scalable, precise lethality, making it an attractive solution for both European forces and international partners seeking advanced, flexible strike capabilities. With Grifo, ARQUIMEA positions itself at the forefront of unmanned warfare evolution. The combination of modular launch architecture, loitering drone technology, and integration with counter-drone systems reflects the operational priorities of modern militaries, emphasizing flexibility, precision, and survivability. Its debut at DSEI 2025 highlights the increasing reliance on autonomous systems capable of independent maneuver and rapid, accurate strikes, signaling how future land combat operations will continue to evolve around unmanned capabilities. At DSEI 2025 in London, MBDA unveiled the Akeron MBT-120, a groundbreaking anti-tank missile designed to be fired from a 120 mm tank gun and capable of striking targets beyond the direct line of sight. Drawing lessons from the conflict in Ukraine, where most tank engagements occur at close range and crews often improvise indirect fire, MBDA aims to give Western armored forces a safer and more flexible long-range capability. The Akeron MBT-120 operates in a non-line-of-sight mode, receiving target coordinates from drones or forward observers before executing a top attack trajectory to strike armored vehicles at their most vulnerable points. Unlike traditional gun-launched missiles that require continuous guidance and expose the tank to return fire, this missile allows tanks to fire and maneuver immediately after launch, enhancing survivability. Designed to fit within existing 120mm ammunition standards, the missile weighs around 20 kilograms and measures just under 1 meter in length. It can be handled, stored, and loaded using the same racks and autoloaders as conventional shells, minimizing the need for structural modifications. Its low-acceleration rocket motor reduces barrel wear while achieving low supersonic speeds, and integration with current fire control systems will require only a simple programming module. Equipped with a passive electro-optical and infrared seeker, the Akeron MBT-120 is resistant to laser-based countermeasures and active protection systems. Automatic target recognition ensures reliable engagement once the missile reaches the designated area. The effective range of approximately 5 km significantly exceeds the engagement distances currently observed in conflicts like Ukraine, offering armored units a clear advantage in both offensive and defensive operations. The warhead selection is still under evaluation, with options ranging from a single-shaped charge optimized for tanks such as the T-72 and T-80 to potential high-explosive fragmentation variants for softer targets or infantry positions. MBDA is collaborating with several European warhead manufacturers, keeping the possibility of a domestic UK solution open. Initial demonstration firings are planned for 2026, with operational entry expected a year later. By introducing the Akeron MBT-120, MBDA provides Western tank units with a versatile, interoperable, and non-line-of-sight strike capability. This development promises to reduce reliance on indirect artillery support, increase tactical flexibility, and complicate adversaries' targeting assessments, as the missile leaves no visible signature indicating a tank is equipped with this advanced system. The Akeron MBT-120 exemplifies how modern armored warfare is evolving, integrating precision-guided munitions into existing platforms to improve both offensive reach and crew survivability. Its debut at DSEI 2025 highlights the emphasis European forces place on innovation and readiness, ensuring that future battlefields favor units capable of rapid, precise, and adaptive operations. At DSEI 2025 in London, NMS UK unveiled the latest Dragon configuration, a 4x4 platform designed to address the challenges of drone-saturated and electronically contested battlefields. Combining a proven protected mobility chassis with advanced sensors, effectors, and signature management, Dragon integrates Kongsberg's Protector RS-4 remote weapon station, MBDA's Sky Warden Counter-UAS suite, Ultra PCS generic vehicle architecture, and Wescom Defense's Atmos mobile camouflage. The result is a patrol-ready vehicle capable of both detecting and defeating small unmanned aerial systems while reducing its own visibility across multiple spectrums. The Dragon platform retains its high levels of protection and mobility, but its true innovation lies in system integration. The stabilized RS-4 weapon station provides precise day and night targeting, laser ranging, and fire-on-the-move capability, allowing crews to engage drones, loitering munitions, or ground threats efficiently. Coupled with the Sky Warden System Manager, RS-4 acts as the kinetic endpoint in a layered counter-UAS network, enabling the vehicle to operate as a self-contained defensive node within larger formations. Sky Warden fuses radar, EO/IR, and passive RF sensors to build a comprehensive air picture at the vehicle level. The system coordinates both soft kill measures, such as jamming and deception, and hard kill responses, ensuring minimal operator burden while enhancing convoy and troop escort capabilities. By sharing tracks with nearby nodes, Dragon contributes to a mobile CUAS bubble, giving units the ability to detect, disrupt, and, if necessary, neutralize aerial threats in real time. Ultra PCS generic vehicle architecture underpins the integration of all systems, standardizing power distribution, data connections, and human-machine interfaces. This modular approach allows sensors, jammers, radios, and mission computers to be added or upgraded rapidly without extensive re-engineering, enabling future growth as new threats or technologies emerge. The mature Dragon chassis, developed by Neural Machina, combined with NMS UK's integration and support, ensures NATO compatibility and accelerated certification for UK and international users. Completing the survivability package, Westcon Defence's Atmos mobile camouflage reduces the vehicle's visibility to EO/IR sensors and UAS-mounted seekers. By disrupting radar and thermal signatures, Atmos allows Dragon to conduct counter-UAS operations while remaining difficult to detect, providing a tactical advantage in contested environments. Unlike many pure 4x4 vehicles that rely on trailer-mounted or mission-specific CUAS modules, Dragon integrates signature management and layered effects directly onto a mobile, ready-to-deploy platform. The key advantage of this system lies in the depth of integration rather than a single performance metric. By combining a mature remote weapon station with a modular counter-UAS suite over a standards-based digital backbone and adding multispectral camouflage, Dragon shortens sensor-to-shooter timelines, simplifies training and sustainment, and preserves future upgrade paths. This capability ensures units can remain dispersed, protect logistics convoys, and maintain operational tempo under constant aerial surveillance without relying solely on static short-range air defense assets. Strategically, the partnership between NMS UK and Nurol Makina blends a combat-proven Turkish 4x4 chassis with UK-based system integration and support. The Dragon's combination of mobility, survivability, and autonomous counter-UAS capability offers European and NATO forces a flexible tool for operating effectively in drone-intensive and electronically contested environments, strengthening both unit protection and battlefield maneuverability. At DSEI 2025 in London, German armored vehicle specialist FFG introduced the Condor, a modern infantry fighting vehicle built on the proven Leopard 1 main battle tank chassis. The Condor transforms legacy armor into a digitally enabled multi-role platform capable of infantry support, air defense, mobile surveillance, and operations in high-threat environments. The centerpiece of the Condor is a newly engineered unmanned turret armed with a 30mm automatic cannon. The turret supports multiple ammunition types, including high-explosive, armor-piercing, and programmable airburst rounds, and features a dual-feed system for seamless switching in dynamic combat scenarios. A coaxial 7.62mm machine gun, smoke grenade launchers, and provisions for anti-tank guided missiles further enhance the vehicle's lethality. The turret offers elevation angles from -10 to +70 degrees, enabling engagement of both ground and aerial threats, while integrated gunshot detection and multi-mission radar provide 360-degree situational awareness and CUAS capabilities. Protection has been significantly upgraded with reinforced side and roof armor, along with a redesigned seating concept to improve crew survivability. A digital mission environment integrates sensor fusion and command and control systems, allowing operators to make rapid decisions under fire. Despite these enhancements, the Condor maintains operational agility, with a combat weight under 40 tons and dimensions of 7.18 meters in length, 3.41 meters in width, and 3.05 meters in height. Mobility is powered by a new generation 8V199 TE23 diesel engine from Rolls-Royce Power Systems, producing 950 to 1080 horsepower, coupled with a reinforced ZF4 HP250 automatic transmission and a two-cycle cooling system. This new power pack is approximately 300 kilograms lighter than the original Leopard 1 unit, offering improved acceleration, fuel efficiency, and a lower thermal signature while remaining compatible with existing Leopard 1 spare parts, simplifying logistics. The Condor is designed for modularity and rapid role switching, enabling commanders to reconfigure it quickly from an air defense platform to a fully armed IFV depending on mission requirements. Remote and unmanned operation modes further enhance flexibility across diverse operational scenarios. By converting a Cold War-era chassis into a modern, digitally enabled combat platform, FFG positions the Condor at the forefront of armored vehicle innovation. The IFV combines legacy ruggedness with next-generation systems, offering a cost-effective solution that meets the demands of contemporary multi-domain operations. With its debut at DSEI 2025, the Condor demonstrates how modernization programs can extend the relevance of older platforms while providing militaries with agile, versatile, and survivable vehicles for today's complex battlefield environments. At DSEI 2025 in London, Rheinmetall showcased the Lynx Skyranger 35, a tracked air defense variant of its KF-41 infantry fighting vehicle. For the first time, Rheinmetall has integrated its Skyranger 35 turret onto a tracked chassis, creating a highly mobile, autonomous short-range air defense (SHORAD) platform designed to operate alongside frontline armored units in high-threat environments. The Skyranger 35 turret features a 35mm KDG 35/1000 revolver cannon capable of firing NATO standard 35 by 228mm ammunition at a rate of 1,000 rounds per minute. It is optimized to engage a broad range of aerial threats, including small to medium UAVs, rotary-wing aircraft, loitering munitions, cruise missiles, and incoming precision-guided munitions, with an effective horizontal range up to 4 km and vertical coverage exceeding 3 km. Its programmable ahead airburst rounds release hundreds of tungsten sub-projectiles to intercept drones and loitering munitions with high precision, making it highly effective against swarming threats and low-signature targets. The system's sensor suite combines AESA radar, infrared search and track, (IST), electro-optical cameras, and laser rangefinders, enabling 360-degree situational awareness and automated threat detection. The integrated fire control system calculates optimal engagement windows in real time, even under GPS denial or electronic warfare conditions, while supporting autonomous operation or integration into broader network air defense architectures. Mounting the Skyranger 35 on the tracked Lynx KF-41 chassis enhances survivability and cross-country mobility compared with wheeled alternatives. The chassis provides scalable armor protection against IEDs, mines, and kinetic threats, while offering active protection options and modular mission kits. This enables the air defense variant to keep pace with mechanized infantry and main battle tanks in dynamic, high-intensity operations without compromising protection or mobility. Rheinmetall is also developing multi-effector options for the Lynx Skyranger 35, including short-range missiles and potential soft-kill systems such as jammers or directed energy devices. This layered capability is intended to counter multi-vector drone threats and swarms, enhancing the vehicle's resilience in modern, contested battlefields. Operationally, the Lynx Skyranger 35 provides close-in active air protection from 500 meters to 4 kilometers in range and from ground level up to 3,000 meters in altitude. Its rapid reaction, automated tracking, and dense firepower make it ideal for defending armored columns, forward bases, command posts, and critical logistics nodes, directly addressing vulnerabilities highlighted by recent conflicts such as the war in Ukraine. By integrating mobility, protection, automation, and firepower into a single platform, the Lynx Skyranger 35 represents a significant evolution in mobile air defense. Rheinmetall's tracked SHORAD solution is tailored for modern combat environments, providing NATO and allied forces with a versatile and survivable tool to counter emerging airborne threats while maintaining operational flexibility across the battlefield. At DSEI 2025 in London, MBDA introduced the Crossbow, a ground-launched missile designed to deliver long-range precision strikes while remaining cost-effective and rapidly deployable. Developed in just 7 months from concept to demonstration readiness, the Crossbow, designated as the one-way effector heavy, targets fixed high-value sites such as logistics hubs, command centers, and radar installations, flying over 800 kilometers at high subsonic speeds. A live-fire demonstration is expected in late 2025, depending on customer support. Weighing approximately 750 kilograms, the missile measures 5.3 meters in length with a 3-meter wingspan and a 350mm fuselage diameter. Its modular payload bay can carry up to 300 kilograms of kinetic or non-kinetic munitions, allowing adaptation to a variety of mission profiles. Unlike MBDA's heavier Storm Shadow cruise missile, Crossbow is designed for launch from standard military trucks, including single or twin configurations in ISO-compliant containers, emphasizing integration simplicity and operational flexibility. The missile's guidance system combines inertial navigation, hardened GNSS with anti-jamming capabilities, terminal sensors, and AI-supported image-based navigation, allowing autonomous operation in GPS-denied environments. This design ensures accurate terminal guidance against stationary targets, while retaining options for future upgrades in survivability, lethality, and platform integration. Crossbow leverages a European industrial network for rapid, scalable production. Partners include Czech turbojet manufacturer PBS Group, Norwegian warhead specialist Nammo, UK drone developer Modini, and aerospace engineering firm Marshall. The system uses commercial and military off-the-shelf components to control costs, allowing mass production and potential sovereign manufacturing for NATO countries. The modular payload bay also permits integration of customer-specific munitions, enhancing flexibility for diverse operational needs. Strategically, Crossbow reflects lessons learned from recent conflicts, including Ukraine, where inexpensive precision systems were used to challenge adversary air defenses and disrupt logistics networks. Unlike the smaller one-way effector variant, which focuses on saturating defenses, Crossbow is optimized for long-range strikes against high-value targets, providing European and NATO forces with an affordable, mass-producible option to complement higher-cost systems like Storm Shadow. The program emphasizes speed, adaptability, and cost efficiency. MBDA highlighted its cooperative European development model, agile decision-making, and industrial capacity as key factors enabling rapid delivery. While cost figures were not disclosed, Crossbow is positioned as significantly less expensive than Storm Shadow, allowing militaries to procure larger quantities for high-intensity conflicts. The missile's design favors practical deployment over complex features, prioritizing robust, reliable performance in contested environments. Crossbow's addition to MBDA's portfolio expands Europe's deep strike capabilities, complementing systems such as Spear Glide and the Akeron MBT-120. Its ground-launched, long-range configuration aligns with NATO efforts to enhance precision strike capacity and massed effects in modern conflicts. With serial production expected in 2026, Crossbow is poised to provide an accessible, versatile tool for European and Allied forces operating in high-threat theaters.